So my name is Ananth Ramesh. I work with the structures team, working on the design, analysis, optimization of the spacecraft. Been there here with TeamIndus for more than 5 years. And when we started with TeamIndus, the first thing that we did is what everyone would do. Google, how do we land on moon? And we got into the first Wikipedia page. And we were that naive when we did start our first lunar mission. That's how we went about going out doing this. We were about 5 people, crazy enough to go to moon, and slowly we evolved to 18. And our coffee breaks were of coffee breaks, we used to just engulf the full team and then we just go out. So when the coffee break is there, the full team is done. So the team mission, the team that is going to go to the moon actually is just 15 people. That's how big we were. I'd want to show you a small snippet, a video that would encompass a small bit of what we've accomplished, and then I'll explain to you all the bits of it. Yeah, the second slide should do it. Yeah. Okay, while we are at it, all right, perfect.
We leave as we came, and God willing, as we shall return.
Today we're challenging private teams from around the world to design and build robotic explorers and race them to the surface of the moon.
To be the first privately funded enterprise to build and land a rover on the moon.
$30 million of money to reinvent how we get to space, how we get to the moon. These people are trying to demystify this entire concept of a lunar exploration. I think this is exceptional. I don't care who you are, what you've done before. The first person to make that happen wins.
We're doing the aerospace solution, which hopefully is going to land on the moon soon.
I think we ran out of doing crazy stuff on planet Earth, so that's the next phase to go.
Everyone here realizes that you're making history here, and I think that's what drives people the most.
The prize money on offer is far less than what it is going to cost any team to do this, and that's the challenge.
We have the talent, we have the caliber, we have the initiative, and we have the motivation. Let's compete at the world and see if we can win.
And I think when they win, India wins.
Thank you. So as you saw, what we've been doing is, we were participating in something called as a Google Lunar XPrize. The Google Lunar XPrize is a public funded, it's a public competition wherein there is a competition that you'll have to go to the moon. Now what is XPrize? Let me just explain to you what XPrize is, and then I'll get to you what Google Lunar XPrize is and what is TeamIndus doing in Google Lunar XPrize. So XPrize is a public competition enterprise, which is a non-profit organization that basically is into creating competitions that would take the humanity to the next level. They just want to do something that's going to be radical, that's going to change humanity for the good. Like for instance, let's just say water is a huge issue. How about we create water from thin air for people in Africa? Women's safety is an issue. How about we create devices that could be very, very easily usable by women and ensure that they are safe enough? So these are all these problem statements that are put up. There are these private people that come in and sponsor these problem statements. One of them happens to be the XPrize, which is the Lunar XPrize. The Lunar XPrize is that we know that the next level of technology is all going to happen in space. Now, how do we encourage the private domain to get into the to get in the aerospace domain? So henceforth, they have put up a challenge to send a spacecraft to the moon, rove 500 meters on the moon. That is it. It's as simple as that. But there are things that come as an effect of it. So when you know how to launch something and land something on the moon, you have created your capability to do something much more. Rove something on something of a planet that you don't know about. You also learn how do you model your rover to do something on Mars. So there's a lot of learning that you can do besides the fact that it is a very, very simple problem statement. So Google happens to be one of the interested private entities that were really excited about the fact that they would want to support this particular mission of XPrize. So that's what the Google Lunar XPrize. And TeamIndus happens to be one of them who happened to be part of this Google Lunar XPrize. And we are the only Indian to participate in that. How sad is that? And how great is that? Can you go on to the next slide? Sure. All right. My apologies for the brightness. I wish it were a little bit more bright. Let me just explain to you what we're seeing here. This is the spacecraft that would take the rover to the moon. As the problem statement is stated, we'll have to take a rover to the moon, rove 500 meters. So there is a need for a bus of sorts, a transportation mechanism that would take your entity to the moon. That is the spacecraft. Now, this spacecraft has been designed to go about the SpaceX Falcon. You might have heard about the SpaceX, the launch vehicle that can come back and become reusable and henceforth become more cost efficient than PSLV itself. So it's beating PSLV on the cost efficiency. So coming back to our spacecraft, we won the first milestone prize, which was set by the XPrize Foundation, and Google gave us $1 million for that specific milestone. What did we do there? We proved a specific configuration that is viable to go to the moon, have all of these objectives done, and we built the prototype, we conducted all of the tests, and we proved that this is capable of going to the moon. Now, what did we do? What is the configuration of this spacecraft? Now, this spacecraft, let me get a little bit technical, perhaps not too technical, but yes, it is required for me to get technical. This spacecraft has a diameter of about 3 meters. That's how much space it takes from the plan view, that is the top view. And it's got a height of about 1.6 meters, not very high. It's got the total spacecraft is about 600 kgs. That is what it can go to the moon. Of the 600 kgs, close to 450 kgs is just fuel. And we will be only able to take a payload, that is usable stuff on the moon, which is worth of only about 20 kgs. That is all. All this money of $70 million will go just to send something about 20 to 25 kgs onto the moon. Having said that, it is very essential that we land something on the moon, ensuring all of the probabilistic scenarios. So that is why we have the highest possible diameter that SpaceX provides us. The diameter is this. Henceforth, we have got a high stable lander, which has got a 3 meters diameter is the lander. We have got a 4-legged configuration spacecraft that will be able to sustain all of those landing conditions. It's going to be a one-time landing, and henceforth we don't have a shock absorber. It's going to be a one-time crashing event. So henceforth it's just going to crush something and it's going to dissipate all of the energy. We've got 16 thrusters and 1 main engine. Now, very interesting thing is, as Indians, we have to be very, very frugal. And henceforth, our main engines, the engines that we have got, was denied by the Americans, saying that we would perhaps copy the technology and perhaps make better thrusters. So we were denied the technology, and henceforth we had to go to a slightly lesser version of the thrusters. These thrusters are non-throttleable, which means that when we are coming in from a very, very high velocity of 10.2 kilometers per second and trying to descend onto moon, we have thrusters that are non-throttleable. Just think of your brakes where you cannot change how much you brake. So it's just one. Grab, leave, grab, leave, grab, leave. That's not something that we want to do. So there's a deceleration is going to be very, very jagged. And henceforth, we have 8 thrusters that's going to support our main engine. The main engine is about 40 kgs of force it produces. And these tiny thrusters around, 8 thrusters, produce something around 2.2 kgs of force. So that will pulse and just keep doing this pulsing. It'll just keep pulse and assist the main engine. So that is some of the innovation that we have done, considering what we have and what we perhaps have available to us. One more very interesting thing that we like to also be very proud of is something called as a dual gimbal antenna. What is a dual gimbal antenna? Why do we need a dual gimbal antenna? While the spacecraft is going towards the moon, one thing is that we have to have constant contact with the spacecraft. And henceforth, we have something called as an omnidirectional antenna that basically you can contact the spacecraft in any orientation of the spacecraft. That's very essential for us. Now, as we are tending towards the moon and we've reached the moon, we will have to have high definition imagery that has to be sent back. So henceforth, we have to have a dual gimbal antenna that has to point towards the Earth. Now, this omnidirectional antenna has got very slow data rate. The dual gimbal antenna has got a very high data rate. The cost of this dual gimbal antenna is close to $6 million. We have built it ourselves with around $200,000. So this is in-house engineering that we have done and cut the costs. Can we please go to the next slide? Somebody, can you? Next slide, please. All right. So what are the payloads that we are doing? You may or may not have heard the Google Lunar XPrize has been suspended because we were not able to get our spacecraft into the space within the speculated amount of time. And henceforth, what we could naturally do, we were thinking of other ways so that we could sustain our mission to the moon. And we have put forth an idea to NASA, and NASA has agreed to partner with TeamIndus. So TeamIndus is again the only private entity that's going to be partnering with NASA, and we're going to send payloads to moon using NASA's money. Also, along with that, we have our own rover. So the rover is there right behind you. This is a prototype of the rover that we have. You could take a closer look at it. This is the exact size that it's going to be, as small as that. And that's because the major payload that is going to be taken to the moon is going to be the NASA's payload and not this. So this is going to do much of our small needed work, like traversing, doing some remote sensing. We're going to take some images, perhaps do some spectrometry, just seeing what are the constituents of the soil and stuff like that. So small stuff is going to be done by the rover. The Japanese are also going to tag along with us. They're called a Sorato. That's number 4 there, Sorato. That's their rover's name, and they're going to be tagging along with us because they don't have a spacecraft. So the Sorato and the TeamIndus ECA, Ek Choti Si Asha we'd like to call it, will be going to the moon along with our spacecraft. We also, in collaboration with Indian Institute of Astrophysics, we have developed our own UV telescope that we will be sending along with the spacecraft. And very interesting thing is Lab to Moon. We have some students that design experiments, and they will also be taking their experiments to the moon. What we essentially want to do is we want to give students an opportunity, or perhaps a way to see what are the questions that we want to be answered when we're going to moon if we want to have a moon village. One of the most essential thing is, can we grow food? Can we have radiations that could be preventable? So we have people that have built up a Van de Graaff generator. Basically, just like the Earth has got a huge magnetic field that prevents the radiation from coming onto us and hitting us. They also want to create some small magnetic field so that they can prevent the radiations coming in onto the moon, because the radiations on the moon are very, very high. So that's the reason why we have these very, very thick space suits that we have. So can we prevent that, and can we have it more lightweight so that we have these huge magnetic generators, Van de Graaff generators, to prevent radiation? So these kids are thinking out of the box. These kids are thinking out of the box, and we have 3 kids from all over the world. One is Italy, UK, and India, of course. So 3 teams will be sending their experiments aboard our spacecraft. Next slide, please. All right, a little bit about our trajectory. Unfortunate again that we are not able to have enough brightness here. So, all right, let me just explain to you what is happening. Is our mission with just the rover cannot sustain more than 7 days. That's right, 7 days. We're going to spend close to $70 million. Now, having that, we need to ensure that we are landing on the moon right when it is so-called early morning there. As you know, The day in moon is 14 days. The night in the moon is again 14 days. One lunar day is 28 days. So there are 7 days that we can sustain. It's sustainable for 7 days. Then other 7 days it becomes really hot, then cold and very cold. So that's how the days go on. We are only able to survive for close to 7 days with the moon, on the moon. So henceforth, considering that, we have ensured that our spacecraft is able to take something called as a lunar trajectory, which the SpaceX will directly inject us into the lunar trajectory. And after that, all of this is Indian algorithm, Indian engineers doing this, ensuring that we are waiting in the lunar orbit until the dawn terminator, which is the sun's rays, when it reaches our specific landing zone. When it reaches there, we initiate our descent and then we do our descent phase. Can we go to the next slide, please? All right. When you look at the moon, somewhere in the northwest quadrant is where you would find, perhaps in the near future, the TeamIndus rover. And one thing that we're going to do is, just like the people of NASA did, we're going to have something called as a small mirror that we're going to keep it there. So if you just want to be sure that India or TeamIndus has sent the rover to the moon and we're not faking it behind some movie, all you could do is that you could have a very, very powerful laser, not cheap enough for people to buy, but nevertheless, if it could be a consortium, you could perhaps buy it, something around 15 grand. If you could strike the laser onto the moon, a specific frequency of light would be reflected back, which will be pre-stated, and you could check yourself if we have landed on moon. So that's where we're going to land, somewhere in the northwest quadrant. It's called the Mare Imbrium. It's a huge crater. It's very, very flat. For reasons that it is flat, that we want our rover not to face too many obstacles. Next slide, please. Next slide, please. All right. What are the engineering challenges that we face in space? One thing, the reason why it is called rocket science is because purely that we have to ensure that every aspect of it has to be taken care of. Even if you miss one thing, $70 million is gone down the drain. Now, one of the aspects that we'll have to look into is the fact that the radiations are very, very high. The other thing is the thermal management. The solar rays that are hitting the sun has to be ensured that it is managed. To give you a small idea, when the spacecraft is looking at the sun, the other side is looking at deep space. Deep space, which is about 2 Kelvin. 7 Kelvin is, it depends upon where it is looking. It's both 150 degrees in one side and minus 167 degrees on the other side. That's how the temperature differences are. And that results in huge problems that are resulted onto all of our subsystems. One of the very interesting thing that perhaps you could relate to is there's something called as a bit flip that happens. The radiations are so high when we are on towards moon. The computer works with ones and zeros, yes, when it's transmitting information between each other. Once it is going through these radiations, an erratic behavior happens wherein these radiation hits these semiconductors and it flips the 1 to 0 and 0 to 1 in an erratic fashion. So we don't know which one is going to be flipped. So henceforth, we also have to ensure these issues have been taken care of by something called as a polling. We have computers in specified positions, and we know that when this specific spacecraft is having this orientation, we will take a lesser probability of answer from this computer, which is located in this direction, because it is facing the sun. So we have polling methodologies that we ensure that we don't make errors and the computer doesn't go crazy. Attitude control is something that... Perfect. All right. One of the other things that you may have seen, SpaceX have gone through a lot of iterations to ensure that the spacecraft is landing back. It takes a lot of effort for them. They've crashed so many times. I hope we don't crash. So SpaceX, have you seen the launch vehicle coming back? It's a huge feat that they've done by themselves. They're able to reuse the launch vehicle's parts. That is something is equivalent to what we're doing. We're not just bringing it back. We're just doing the same thing on moon. So having to land something itself is a huge technology. We do not learn it from anyone. There's something called as ITAR regulations that you may or may not have heard of. ITAR regulations prevent anyone from sharing this technology to anyone. So it's completely made by us. So we do not have the money to waste that by losing the spacecraft all the way to the moon. So we have to do all of our calculations and computations here on Earth. And as many of you may or may not be aware, Aadhaar card, in spite of the fact that there are so many errors and there are perhaps Aadhaar cards created for dogs, the efficiency in which it corrects itself and improves is exemplary. And we know about that. And henceforth, we have recruited the person who's in charge of Aadhaar card to work for us to improve our algorithms. And it's done a huge help for us to, so we have people of Aadhaar card working for us. Very quickly, why do you think we are going to the moon? It's very simple, because 90% of the energy that is consumed by the launch vehicle that goes to the moon is just to escape the Earth's gravitational field. So when we reach out to the moon and if we are able to go and settle down in the moon and use the local resources to go elsewhere, perhaps to Mars or something like that, we'd be using much lesser energy. So thenceforth, to put it very simply, moon is a very simple base that we can use it as a laboratory. Like if you want to check how well your space systems work in vacuum, and if you want to see how grass or cotton or any of it grows, how do humans behave in vacuum scenarios, how does human psychology turn out to be in such isolated situations, all of this is certainly a laboratory that we have to conduct on the moon. Let me skip the future tech. All right, let me end this by a very interesting thing. TeamIndus is filled with, the average age of TeamIndus person is something around 26 years of age. And we have a combination of white and black, as in white hair and black hair. The average age of our experts is something around 70 years. And average age of engineers is around 26 years. We combine the energy of these young engineers and with the expertise of our experts, and we're able to do something like this. And NASA has is partnered with us. And one very thing that we'd like to do, and what we're doing is we go about empowering little girls, little kids to see what they can do and perhaps challenge their own ideas of what they can become. One very interesting thing is that there was this one little girl whom, after seeing our spacecraft, said that I had a very, very small ambition, but after seeing what you guys are doing, looking at our spacecraft, this little girl said, I have to match this ambition. So if we are not allowing, even if they don't get into the aerospace domain, it's fine, but at least we are setting them a bar. Like, this is where you have to think, perhaps if not this or something else which is equivalent. Thank you for this opportunity. It was great for you. Thanks. I can have question and answers for 2 minutes, 2 or 5 minutes. 5 questions at max. Yes. You could ask and I could read. Okay, that's great.
Hello.
Hi.
Hi. So probably I saw the same episode on Discovery Channel or something. Yeah. Yes. Where this means how one single person had a dream, then he started collecting the people together, and that is how probably this team is formed.
Yes.
So just for my clarity, it is like because probably towards the end when the rover is under preparation and there are like series of tests which are done, like phase 1, milestone 1, milestone 2, something like that. So after that I was not aware whether the actually the project took off and you landed or not. So still it is not done, right?
No.
Okay, yeah, thanks. Best wishes for the future.
Thank you.
Hi, Ramesh. This is Sagar.
Hi.
I'm also aerospace guy. Okay. So actually, very great work. I also heard about TeamIndus. So
thank you.
My doubt is not related to aerospace. Are you getting any funds from Government of India, Make in India, something like that?
All right.
Or how you are getting support? Because when you're talking about thrusters, it's like solid propellant you are using, I guess. Right?
Liquid propellant.
Liquid propellant. Okay. Yeah. Are you getting any support from Indian government?
All right. Okay, let me just break this down to you. The political system is very helpful. but the bureaucratic system is not very helpful. They see us as competition. They see us, as I stated, 26-year-olds coupled with 75-year-olds. They just can't handle that. So there's a lot of friction that's happening, and that was one of the primary reasons why there could not be some. It could not ease into the PSLV. We were supposed to be launching through the PSLV. We couldn't do that. But I hope that they don't see us as competition. We can work together, and there is a lot of friction to put in. So there was not very much support from the bureaucracy. Now, answering your funding question, firstly, India is very, very risk averse. They don't see, unless and until you deliver something, they do not pay money, in spite of the fact that we have all the capabilities. You may have heard the amount of people that work in NASA, so or wherever, or Google or whatever. If they can do it there, why can't we do it here? It's just that they spend money. They're okay to fail, and it's just that we are just not okay to fail. And perhaps we don't have the money for failing, so that's why we're glad enough that we have NASA's support, and perhaps in 2 or 3 months we'll be inking the deal with NASA to send a spacecraft to the moon, and perhaps a series more after that.
Okay, thank you.
I'll come to you after this, certainly. Yes.
Yeah, my name is Sridhar.
Hi, Sridhar.
Great work what you're doing here. So is your team fully recruited? Are you looking for more people to join? Obviously, they should be experts, the best in the field and all that. But are you fully recruited? You still have openings for different positions in this team?
It's a very good question. I think this would require some amount of explanation. Let me just step back 1 minute. So NASA has given acknowledgement saying that we would be going along with you. Now, this specific U is actually Orbit Beyond, which is TeamIndus's sister company, which is in the US. So after NASA inks the deal, Orbit Beyond would effectively buy off TeamIndus, and henceforth from there is when we would start recruiting. But up until now, since we have a technology prototype and all of it done for now, we don't see any recruitment process happening right now, because we have hit the so-called glass ceiling as to what best we could do considering the scenarios. When we get to the next phase, when we ink deals and all of that, there's going to be a huge explosion of requirements.
Sure. Thank you.
We're going to do one last question. And then Ananth is here. You can catch him before he goes to the moon.
Hi.
Hi. First thing, congratulations. What you're doing is really awesome. Yeah. I have 2 questions actually. The first question is whether you're considering ion drives at any point of time.
Pardon me?
Ion drives.
Okay.
Instead of liquid fuel. And the second question is say the closest equivalent to you guys is SpaceX. So SpaceX has Musk, and he has Tesla, and he has access to money, and you all guys don't.
Yes.
So basically my question is whether you all guys would be considering some kind of a business model related to the technology that you have on Earth, so you can build what the VC funds or whatever consider proof of concept and generate revenue over here to fund your operations. Yeah, thank you.
I think these are very interesting questions. The first question is with regarding to ion drive. Let me just explain what ion drive is, why it's so great, why are we using or not using it. Okay, so the ion drive, for those who may not know, it's a very high efficiency. It has got 10 times more efficiency than or 20 times more efficiency than a solid propellant, 10 times more than liquid, and 5 times more than a cryo. So it is very efficient. But where does this efficiency come down to? The effective thrust generated by the ion is very low, something around newtons, micronewtons, somewhere there. It's there. So we will not be able to use 1 Newton, 2 Newton to thrust something that is close to 600 kgs all the way to the moon. Having said that, but this plays a very important role. I'll have to get a little bit into physics again. You may have all heard F is equal to ma, and if F is 1 Newton, we could constantly keep accelerating to the extent that we could even reach light speeds if there is no gravity pulling us back. So these ion thrusters would be of use once we have escaped the Earth's gravity, and where this can start making sense in terms of displacement. Even that smallest force, if it can create the smallest displacement, then it will start making sense. And that would only start making sense when we are interplanetary mode. So I hope that answers your question as to why or why not. We will not be using the ion thruster for these reasons, at least for up until now, for the technology that we have. The second question is Elon Musk and us. Yes. So one thing is that we are collaborating with government agencies. One of them that you know of is, which I've shared with you, is NASA. We are also working with DRDO. We'll be working with them to make their satellites. We'll also be working with the Dubai Space Agency. They also want to work. So we have our engineers in Dubai right now, seeing how we can collaborate. So to set the ground running, we need stuff like this before we start innovating and taking the first stride, like how SpaceX is doing from the money of Tesla. Until then, we can only be second step. Like, we could do what has already been done, but it is still good enough, like landing something onto moon or something like that, because that's something which only 3 countries have done: Russia, US, China, and perhaps now Israel is perhaps going to do it. Fingers crossed. I hope they do it for the sake of space community. Thank you all.